most of those VR headsets don't actually have a button. Yeah, you would expect a button would be touching the screen. Mostly when you have a phone and do a magic window experience, to trigger something is to touch the screen. It's not really refined. It doesn't say touch left, touch right. It's just touch the screen. And that's where this comes from, this whole idea of the cardboard, the moving cardboard, where basically this is a V2 version 2 of that. The first one had this magnetic thing, which was an RFID kind of thing, but didn't work with any Samsung iPhone, because they didn't have. Anyway, the point is, it's more physical, like really touching the screen. So you have like a touch glove thing, fabric that touches the screen. So that is like triggering something. But you can't assume that. And that's why the most lowest common denominator of interaction in VR, and that VR, is actually gaze, looking at something and then triggering something with a certain delay. So some of you might have used some VR applications, even if it was Unity-based, doesn't matter. You look at something, you look at it for a little while, and the loader comes and then it executes. That is gaze-based control, right? Trigger-based control or touch-based control would happen if you have a trigger. Now, most of these headsets here, and you can play with them later, they have like little triggers which basically simulates you touching the screen, right? But that's not something you really can assume unless you have control over the hardware. And then you can augment this whole thing by attaching a Bluetooth controller, or you have a 3-dot controller in the Gear VR, Daydream, or the Fove, or all the others. So like you can enhance and improve the inputs and the controllers based on the control on your device. But if you don't have a control of device, think about it just with like steering and then time click. And there's very much out-of-the-box stuff for A-frame already that handles this kind of interaction, right? Where did I go back? Okay. So here in this case, it's pretty much, it's making an object clickable. Let's say I do have a cardboard VR headset, like one of those, and then I say I want to trigger something when I touch the screen. Now I can't touch the screen when it's in here, but this one does touch the screen for me, right? So I'm saying I want to make something clickable. I'm telling an object to be able to be clicked. And here I'm basically adding to that object an event listener that tells me if I roll over it, I'm entering with the mouse, which is the little reticle, the cursor in the center of the screen. If I roll over it, change the color of the object. If I leave, change the color back to what it was before or something else. And then if I click it, just like if I click on a button, change something. So you tell an object when I look over it, with that little reticle in the center, click, that's the thing that makes it happen, right? So adding a component to a sphere, and the component is clickable. It's just like a standalone component added to the list of other things. Like, you know, okay. If you want to dive into what kind of components are out there, there's a library for that, a registry. Some of them are from me. No. Some of them could be from you, maybe in the future. I mean, this is an open thing. You can just submit stuff and have people help you build better things and make this experience more powerful, more rich. There's very, very great libraries that create complete environments. You can build oceans. You can build stuff. Like there's really good libraries, physics libraries, where you can turn a room into like zero gravity to gravity on Jupiter. You know, like you can manipulate a lot of things to make this a really rich and powerful experience. And a lot of very smart people build a lot of components that can be reused, manipulated, and changed. Yes?
I was just going to ask, if, has anyone joined the A-Frame Slack channel?
Yeah.
Yeah? Yeah, I would recommend joining that. Everyone here should join because there's, you know, all the co-creators from A-Frame and then the whole global community on there. There's channels around projects, filing bugs, issues, questions, and it's a great place to start contributing to the framework.
Yes. So latest docs are 0.8.2, officially 0.8, but there's a few bugs that I don't like, so I just say 0.2. And then there's a very good tool called the inspector, that you can open up. And we're going to see this when we're doing the workshop, and I'll show you how to use that. It's to manually position objects to get a little reference of where things are in space, because it's kind of hard to figure out things just with numbers and code. And before we get started, this is like a must-see. Look at that poor guy. Come on. It's funny for us, right? Anyway, the point is just if you're creating something, think about the human first. Be empathetic, and figure out you're exposing people to stuff, right? Okay. So in order to get started, I will walk you through my A-Frame Meetup GitHub page, and then we're actually starting with Glitch, which is, these are the 3 experiences we're going to build. This one is a simple box, a set of boxes, and we'll talk about mixins and creating content with just JavaScript. This is a little space experience where you have animation in it, and this is actually a physical space where you can have a physics component in there, and you can actually click that ball. So there's some components in that too. So it's a very incremental thing, and I think we can fly through those pretty far because does anyone have issues with JavaScript in this room?
Probably just me.
You'll be helped. Kieran will love to help you. No, but you basically no one has issues building basic websites, I assume, right? Yeah. Well, we'll see. It's 100, so I'll be fair. Okay, so we talked about the WebXR week, we talked about the global WebXR hackathon, which you're all going to submit something after this course, obviously, it's like slowing through. And the resources, let's get started. Do we not get a little break? 10 minutes, since I talked like so long, so you're all tired now? So stretch your legs. No? You all good? Ready to start? Wow. Troopers. Okay, let me just hide my email madness. Okay, so this is, if you go on rolanddubois.github.io, A-Frame Meetup in New York City, this is my GitHub repo for this A-Frame Meetup group. So if you feel like what I'm teaching you right now is like for babies, then you can go down the line and see the real stuff. I mean, the real stuff, more intense stuff, right? So you have access to everything I'm telling you now inside of this GitHub repo. You're welcome to clone it, copy it, paste it, and submit it as hackathon submission. Just kidding. So I basically have all my presentations in this, and I'm going to post this presentation also in the end of this one. But here we have links to the actual builds. I can show you right now. This is the build. This is a build, right? And this is going to be a build. Yeah. Whee. Wait, don't go away. He shoot you. Quickly, before he falls off the rim. Damn it, he's too fast. Click, and I turn into a soccer ball. Yes, FIFA. Too bad the Germans lost. Yeah, anyway. Can't expect anything anymore. Anyway. And this one is another experience that was built with some components, with waves and this and other. This is not going to be covered today, but here in this case we're using 3D objects, animation, and teleportation, right? So if you want to learn about that stuff and you feel bored with what I'm teaching you right now, just dive into the documentation on that one, right? And here's a little physics game I built last time, which has to do like basically dropping a bowling ball and kicking liberty into the abyss. No pun intended, and not political at all. So. But yeah, so it's a game, right? Anyway, the point is it has to do with objects and physics and positional tracking and stuff like that. So, and this one, and we can actually, maybe later, I'll just pull that up. This is, let me see how I'm doing this now. Yeah, basically, nope, that's not it. But that's my presentation. So all the presentations are basically underneath the images, and then you can actually see, yeah. Then you go and you can print out that poster, or you just pull out your phone right now and look at this right now with your phone right now, and you can see the augmentation of Propellify. So why don't we do that right now, just to see how that works. If you're too far away, you can come closer, just to stretch your legs, because we're not be starting the code in a second. Does it work? So if you don't get the QR code, just type in this URL and then look at the marker. And hopefully there's not reflection, which means that, I don't know if it's reflection means that you can go super. Who sees it? No one? Still far. You can come in front, please. Right, let's stretch our legs. We're going to have a code session in a second. Let's look at it. So you're going on your browser, and then you type in that thing, and then you should see something, right? Working. that's basically a green box in space. Now everything is assumed in this environment, right? So you're assuming that the position of the box is 0, 0, 0, you are 0, 0, 0, you have cursor controls, so you can actually navigate with your cursors, and the only variable I give this box is green, which is the color.
How do you move around before
With the cursors.
WASD?
Yeah, or the cursor. Yeah, both work. Yes, WASD works too. Yeah, so you can use WASD. So now if I can make this a little more exciting. I realized that okay, so let's upload some assets. So for an example, let's do how do you get the asset? That's the question. Because I can, if you go on the in my GitHub repo, and then you download the GitHub repo, then you have assets in a folder. So if you go there and you say clone or download, right? Then inside of the demos, there's an assets folder with all the nice assets that you can use in this experience. And one asset is this. I'm just going to put it on the desktop. In Glitch, you have an asset folder here. In order to get stuff on Glitch, you'll just drag and drop it inside of it, and then copy the URL. That gives you some kind of cryptic URL, but that's the way Glitch works. We have to deal with that. So I'm giving it a material component, and I'm telling the material source, SRC, to be that link. And now when I get out of there and I look at this, then I have the gradient, right? Make sense? So I'm going back to the code. I'll show you what I did. So we remember the material component, right? And I just copy and pasted the URL that I got out of this when I click this copy, right? Make sense? But who is so far following me, and who has issues following?
I just have a question in terms of a box and material. This is the shortcut because the underlying with metadata, or how you describe it with the geometry, is a default for the box position, rotation.
Yeah. Yeah. So a box is basically a frame primitive. It's basically a template for describing a entity geometry primitive box. And we're actually going to go to make it a little bit more clear. We're going to describe an entity to keep it as pure as possible. I mean, describing a box, a sphere, and all this stuff is a shortcut. It's nice, but for our purpose to really understand how we can change little pieces of the puzzle, let's go down to the essence of it, right? So I do geometry, and then I say a primitive, box, and that geometry would have then width, height, and length. Sorry. Right now they are on default all one unit, aka 1 meter. And yeah. And then we have material, which is color, source, glossiness, all that kind of stuff. We do source. We should be seeing exactly the same things we saw before. That's in a different tab. Okay, so one thing that I was showing you in my demo was me sitting in the chair. That was an equirectangular photo, right? You all probably have seen like those 360 cameras that come up and pop up with the two spheres facing each other. They basically are taking a 360 distortion, like a 180 and 180, and stitch it intelligibly together to create some kind of world map from the position of the user, or from the camera position of the world around you, right? Now, those to describe those kind of bubbles, they're called sky components, like, so we can say a sky, and I can tell so sky is nothing else than a primitive of a sphere with an inverted face, which means you can see it from the inside but not from the outside, and a radius of 15 meters. So very far away, where basically your like depth perception stops at a certain degree from far away, right? So it's turning flat, and that's where then they spin out this equirectangular photo as a texture inside of the sphere. And what I'm going to do now is I'm going to give this gradient, turn this gradient into my background, because I'm putting myself inside of the sphere with the sky. Position is 0, 0, 0, 15 meters from the center radius, and I'm inside of the sphere. And that's going to be the sky. And in order to give this box a different texture, I'll just say color red. And also, I don't want to always move my cursor, I just want to position the box in front of me. Which is 0, 0, and then no, fine. Double check this real quick. Yeah, so in front of me is -4. Position is X, Y, Z. X left to right, Y is up down, Z is front back. And if something should be in front of me, I should subtract the axis from me. So I say 4 meters in front of me is -4. And me is 0, 0, 0 because I didn't give me a position, right? And me would be then the camera, or the camera rig, which is wrapping the camera, right? You can imagine the rig of being like your head, or the headset, and the camera, your eye, right? So in this case, I'll lift it up a little, and let's say 1 meter up and -4 meters in front of me, and I'm living inside of this beautiful sky, and that's what it should look like now. Okay? Makes sense? Now, I'm going to give this box some fancy texture. I don't know if you all downloaded the textures yet, but this is the texture I'm going to use, right? Download it real quick. Same procedure as before. I'm going to desktop and then push it into my assets folder. And then I'm copying the URL, copy URL, right? So when you create textures for your VR experience, it's always better to have a potential of 2 texture. Who does not know what potential of 2 is? Yeah, it's right, 2, 4, 6, 8, 12, 16, not 12, not but 16, and then 32, 46, all this kind of, like 200 by 265 by 265, 1024 by 1024, 512, 512. Those, because then, because WebGL digests proportionate potential of 2 numbers faster and better. It makes sense to create your assets and your textures in a potential of 2. So if you have a rectangular image, it could be 512 wide and 265 tall. It has to always be a multiple of 2, right? You know. But if you don't have that, you can add some kind of tag to it that says MPOT true, which is not a potential of 2. So, but that's just for performance later down the line. Just want to raise the awareness. If you're using assets, make sure they are like in a good resolution, but a multiple of 2, right? Okay, so we copied the URL of this texture. And now I'm going to add that as a source for an image here. And sorry. And then I'm going to add animation to this box so I don't have to walk around it. I just want to look at it because it's so pretty. Just copy paste the entire thing. Actually, I'm going to copy and paste the entire thing and then explain what I'm doing here. How about that? And you guys can see. So, assets, and I have to copy texture. And gradient. Okay, so like sky or box, light is also an entity, an element that has property that emits light. And there's 3 different lights. And I would suggest you go through the docs and look at all these different kind of entities down here, the components and the entities, the primitives, we have light, and all those have like attributes and variables to look and dig through. But the point is, if you ever touch any kind of 3D environment, there's like spotlights and ambient light, and it defines whether a light comes from a direction and highlights something, casts a shadow, or it's just irrelevant where the light is positioned. In an ambient light, it could be underneath the scene, but it still would light up the scene in a comfortable kind of flow. In this case, there's two lights come with A-frame out of the box. If you don't define any light, you'll get 2 lights. You get an ambient light and a directional light. And usually it's around behind the camera to cast a shadow backwards. So kind of a nice little comfortable light shine. But if you want more control about this, let's say you want to make a gloomy scene and have some fog and have some kind of shadows casting and make it mysterious, then you would probably change the lights. And as soon as you add 1 light element into your A-frame scene, it will change from the default to your custom lighting. A-frame is generally giving you a lot of things out of the box just to give it a comfortable creation environment, but you can customize everything about it. And you can even dig in deep to get into the 3JS layer to really make it yours. Okay? So in this case, I'm using a directional light, which is white with a normal intensity, a little bit to the left, up, and a little bit in front of me, so it hovers a little bit above me. Why do I do this? Because I want to showcase, in this case, I want to showcase that the box that I created, which is now not anymore 1 by 1 by 1 meter, but different, like it's a little less than that, I want it to have some kind of metalness, some kind of shininess, so it reflects. and I wanted to be a little less rough. Rough means that the light spot is condensed, right? You can make a very rough surface or very flat surface. Make it shiny. You'll see how that looks in a second. I'm not going to animate it yet. I'm going to take this out right now. But this is basically what we had before, except that we are giving it a rotation, a position, more material variables, and the geometry is now not anymore default size. Like this way, this thing looks like this now, right? But if you look around, so you can navigate around it, so you can kind of see